Okay, so for 5.7 number 1, I'm supposed to take y double prime plus 9y equals tangent of 3x and use variation of parameters to find the particular solution. Okay. What do I need to do to have variation of parameters be a game I can play?
Two solutions.
Okay, the first thing I need is 2 solutions to the this. No, to the homogeneous version. Okay, so I make the homogeneous version. So I go yh double prime plus 9yh is 0. Solve that.
So r would equal plus or minus I, plus or minus 3i.
Okay, so r squared plus 9 is 0, so r is plus or minus 3i.
YH would be C1 E2.
Okay, so yh is c1
cosine 3x.
cosine of 3 variable is x apparently. And then plus c2 sine of 3x. Right? Okay, then I need to take that and do
Y is C1Y, or U1Y1 plus U2Y2.
okay, so take that and think at it. What if C1 was mu1 and what if C2 was mu2, right? You guys with me on that? Okay, so I should figure those out. So my guess, right, is going to be y is mu1 cosine 3x plus mu2 sine of 3x. And then you have to get out your equations. So what are your variation of parameters equations?
That would be mu1 prime y1.
mu1 prime, and then this should be y1, which
Yeah.
I'll fill in a second, plus
Plus
mu2 prime
y2
times y2
equals 0.
equals 0. Okay, so that's my first equation. And then
Same.
And then it's,
Prime
yeah,
everything.
all of
Derivatives
them
for the
prime.
y's.
the same thing with derivatives for the y's. So mu1 prime y1 prime plus mu2 prime y2 prime
Equals
equals,
f over p naught.
yeah, your forcing term divided by your initial, or sorry, your forcing term divided by your coefficient on your y double prime, which in this case is 1. So your forcing term. Oops. And I should leave myself some more space because obviously I meant to fill in something. So that should be a tangent 3x, right? And I probably should go back and leave myself a little space to put in a y1 prime and y2 prime. So that should be y2 prime. This should be y1 prime. And then I should go fill in bits, right? So y1 was
Cosine 3x.
cosine of 3x, so that should go here. And then cosine of 3x prime is
Negative sign, or negative 3 sign
Negative
3x.
3 sine 3x.
negative 3 sine 3x. And y2 was sine of 3x.
3 cosine 3x.
And so y2 prime is 3 cosine 3x.
Now you can pull the 3 x's out, right? And that would give you a sine of, it would be 3 sine of 1 and 3 cosine of 1. Would that be a legal move? You can't pull it out of the...
Yeah, you can't factor it out of there. That's the argument in the function, right? You're doing sine to 3x and you're doing cosine to 3x. So I'm afraid you can't get those out. But what you could do is you could be like, yo, that thing is going to look a lot like tangent if I fiddle it around, right? You'd be like, yo, tangent is which one over who one?
That would be sine over cosine.
That would be sine over cosine.
So you-
So if I get sine over cosine here, I could maybe get rid of the tangent over there, right? So I'd be like, all right, let's see, if I take this
Solve
thing
Formula 1.
and subtract the sine-y stuff I'm going to subtract mu2 prime sine of 3x to the other side. I'd get mu1 prime cosine 3x equals minus mu2 prime sine of 3x.
Were there limits on x?
So then divide both sides by cosine 3x.
Yeah, were we?
Divide both, sorry, say that again?
Saying were there any initial like limits on x?
Just where you can kill tangent, so negative pi over 2 to pi.
Well, I mean like
Oh, you mean my intervals for, or you mean initial conditions?
intervals. Like for this one, it's on the test. It's x greater than 0. Is there anything like that?
No, apparently not. But the tangent function, right, is going to impose some limits. So at best, I could hope for things between minus pi over 2 and pi over 2 if my initial condition is in that interval. Otherwise, I could hope for an interval pi wide somewhere.
The 3x would.
Oh, sorry,
Push that
and the
in.
3x will change that, so
pi
it's
over 6.
minus pi over 2 to pi over 2 in terms of 3x. So there'll be minus pi over 6 to pi over 6. So best case, I can get an interval that's pi over 3 wide someplace. But I don't have initial conditions, so it doesn't matter. Let's see, so over here, you want to divide by
Cosine 3x.
cosine of 3x. So multiply by 1 over cosine of 3x. And while you're at it, you may as well multiply by minus 1 over mu2 prime.
Yeah.
So
So if you divide by cosine, right? So divide both sides by mu2 prime cosine of 3x with a minus sign.
So you get negative
So-
mu1 prime over mu2 prime into tangent of 3x.
So I think I got tangent of 3x is mu minus mu1 prime over mu2 prime. Right?
So does that imply that mu prime is negative sine and mu2 prime is
I don't know yet.
cosine?
So I think what I have here is, oh, I did something really stupid. Why did you guys let me do this?
Because we don't know.
Dividing by 0.
You
You
did.
guys don't know what you're doing? You should know what you're
What we were
doing.
just asking about.
Well, yeah, that's why I was asking about the initial conditions.
No, so it's not the initial conditions that are the problem. It's just I've done something idiotic because this was the dumbest possible technique to use to solve this. Yeah, so my problem here, right, is that now I still have an equation with mu1 and mu2
Yeah, that's
primes
right.
in it,
Yeah.
which is
You
dumb.
want me to divide it
Why
by
did we
mu
do that? Let's
prime.
not do that. That was super dumb. So instead of doing that, I want something to add up to 0 here to get rid of one of my prime things, right? So you might be like, okay, pretty clearly
Oh, you should have
I need to get these guys gone. You guys see that?
Yeah.
Well, didn't we just do that?
No, because I still had them in there.
Cosine of
Why?
sine.
Couldn't you just replace your m1 or your mu1 prime with your equation you just came up with?
Yeah.
Or you could add, you're thinking 3 of the first two.
Sure. You could substitute. I'd probably do this.
Because it's cosine.
Okay, there are a million techniques to do this. What I'm going to do is I'm going to multiply this whole equation by 3 sine of 3x. And I'm going to multiply this whole equation by 3 cosine of 3x.
Just
You don't need
cosine
the
3x,
3
you don't need
on
the
that one.
Oh, I don't need the 3 on that one, just the cosine. Okay, so out of that, I'm going to get 3 mu1 prime sine of 3x cosine of 3x plus 3 mu2 prime sine squared of 3x equals 0, hopefully still. And on the bottom here, I have minus 3 mu1 prime sine of 3x cosine of 3x. And then I have a plus mu2 prime, 3, plus 3 mu2 prime cosine squared of 3x equals, and tangent was which one over who now?
Sine over
Sine
cosine.
cosine.
Sine over
So-
cosine, so the cosines
Sine
cancel. So I get a sine of 3x there. And then I want to do this guy, where you add those together. This stuff and that stuff are the same with opposite signs.
Mm.
So I think I get 3 mu 2 prime sine squared of 3x plus 3 mu 2 prime cosine squared of 3x, which should feel hopeful. And that equals
Sine 3x.
Sine 3x.
sine of 3x.
Negative sine
Little bit.
3x. Oh, wait.
I'm adding. Okay, and then you might note, out of this junk, you can factor a 3 mu 2 prime and be left with sine squared plus cosine squared. So that will get you all the way to,
Does the 3x dork any of that up or not?
no, doesn't matter, cool. So just think 3x is theta, right?
Cool.
So there's a reason that when I usually say that, I say sine squared plus cosine squared is 1. As long as the arguments are the same, it doesn't matter what they are, but as long as they're the same arguments. If this was a 5x and that was a 4x, then yeah, you'd be hosed.
Sad.
Which would be horribly sad. So I got 3 mu 2 prime is sine of 3x. And then presumably we could, like, I don't know, multiply by a third or something. And get mu 2 prime is sine of
1/3.
sine of, sure, a third sine of 3x.
And then integrate.
And then integrate. So you get mu 2 is, let's see, I think I get a negative cosine of 3x for sure. And then I think it's over 9 plus constant. And I should check by differentiating.
Yeah.
Yeah.
Cool. And then what?
Plug the YouTube prime into the something else.
Yeah, so plug mu 2 prime into something else, like maybe this something else.
Yeah. Something like that.
Do some doctor stuff.
So I think I got then mu 1 prime times cosine of 3x plus sine squared of 3x over 3 is 0.
Subtract the other side, divide by cosine 3x.
Okay, so subtract and divide, get mu prime is minus tangent of 3x
Tan sine.
times sine of 3x over 3. Oh, which was probably not a good way to do that. Probably shouldn't have bothered to simplify. So let me leave that as minus sine of 3x over cosine of 3x and a 3.
Could we say that sine squared of 3x is 1 minus cosine squared of 3x and then?
Yeah, we probably should. Because that, like basically I'm, okay, I don't know, like maybe u sub. It's quick in your head, try u sub, right? You let u be cosine and du is sine. Then you're jacked because there's an extra sign in there. Okay, see that?
How about u is sine 3x and du is cos? Oh wait, never mind.
Cosine's on the bottom, pain in the ass. Yeah, so maybe u sub ain't gonna do it. So I go to trig identity land and I say, let's see, so sine squared is 1 minus cosine squared, right?
Which would split up into 1 over cosine 3x.
So I get minus 1 over 3 cosine of 3x, and then a plus
Cosine of 3x.
cosine of 3x, I think.
Over 3.
And with an over 3. Okay, and the good news is I can integrate the second part lickety split. The bad news is that the first part takes
The secant.
takes an antiderivative of a secant. You guys remember how to get those?
The secant squared one is with tangent, right? But for cosine or something?
Yeah, the secant squared is easy. Okay, so let's see.
I'm trying, is it 2 sine x cosine x?
Oh, I don't remember. I have to remember where to get it from too. Oh, whoops, I needed my guess. So. Oh, I guess I have a guess up there. Okay, so let's see. Principally, I'm integrating 1 over cosine of x dx. Let's see. So what's the method for these?
Hearts, maybe?
I don't remember off the top of my head. It's been a while since I've taught Calc 1.
Or are you even able to do it, or is it kind of something like a nightmare?
No, you can do this one. Yeah, okay, it's Calc 2. Fair enough. Let's see. So your options are try u sub, right?
Yeah.
So you'd let u be cosine. You don't have a du. You might try to put one in, but then you're in the same rigmarole we were in before, right?
Mm-hmm.
You still got another sine in there to deal with. Okay, so that probably ain't gonna do it. So then you might try parts.
If you do that a couple times, you might notice it.
Yeah, I think parts is where you go with this. So then the question is, which part do you put where? And what are the 2 parts?
1 and secant.
Yeah, so I think your parts are 1 and 1 over cosine, right?
If you integrate
So
the
you
1
don't know how to integrate 1 over cosine, do you?
No.
Because if you did, you'd be done already. So that one's going to go over here. So you're going to do cosine to the minus 1 of x. Oh, that's not cosine inverse, though. That's cosine inverse. Right? That's a reciprocal of cosine, not arc cosine. And you're going to let dv be 1 dx. So v is going to be x. It's going to be x, of course. And du is going to be minus 1 over cosine squared x times get a word times sine, right? The x derivative of cosine is what I'm looking for, right? Which is negative sine. Cool.
Yeah.
So I got my integral of
UD.
secant is uv, so that's
X over cosine.
x over cosine x, right? That's x secant. And then I need minus the integral of
X du.
v du. Oh crap. Thought this was gonna work.
X sine X over cosine squared.
X sine x over cosine squared x dx. Which felt like it was going to work for a minute because I didn't anticipate the x. What's up?
I've been in a table, I can just tell you what the answer is.
Well, that's boring.
We're on the wrong
Well, wait,
track.
so if you did.
Oh, we're on the wrong track.
Yeah, it should come out the log of the absolute value of secant
Yeah.
plus tangent u.
Well, ln.
Secant, absolute, secant x
3x in this case, right?
plus secant x plus tangent x, close absolute value plus c.
Oh.
But we don't have.
I don't think parts can give you something like that, can
So that's the integral of secant of x?
Yeah.
Yeah, that feels like parts probably ain't going the right way.
Because if we keep integrating the 1 and
Oh,
the
what's
x,
the
then it's
trick?
squared and we'll-
There's a trick.
Yeah.
Oh, the trick's dumb. The trick's,
Secant squared plus
This is one of these, you let y be 1 over cosine, right? And then that means that cosine x times y is 1. Then you differentiate both sides and solve for y prime. Sorry, my bad. Wrong trick. You ever would have tried this? Not in a million years? Why not? It's so it's obviously such a great trick to know. So implicit differentiation, right, is actually a good last resort trick that we don't dwell on enough. At any rate, whatever the point of this is, I got my mu2, right, was, and really, right, if you run into this on a test, what do you write at the end here?
Just slap an integral on.
Yeah, just slap an integral on that thing and let somebody else deal with it. Right? Or deal with it later, like come back to it. Right?
So like Calc 2 class.
Definition of an integral.
Yeah, assign that as an exercise for the Calc 2 class. Is a time-honored graduate student tradition. I'm too lazy to do this integral. I'll assign it as a quiz and see if I get an A student who gets lucky on it. Sometimes it works. Okay, so in the end, I think I got y was mu1, which is, this horrible thing, right? So I got minus 1/3 times the integral of secant of x dx
We gotta integrate that.
plus cosine of 3x over 9.
If
Oops,
you,
not
if you
cosine.
take a 1/3 out, a negative 1/3 out of everything, that second part has to be negative, right?
Yeah, sure. You could factor some stuff.
What's the first one?
So this whole thing, right, is your mu1. And then, did I dork something up badly?
This sign, one's positive, one's negative, so
You factored out the negative.
I didn't factor in a negative.
you did.
No, I just factored it out of that piece.
Yeah. Okay.
Oh,
Okay. Yeah.
Okay, and so I had my mu1, and then I should have times,
cosine.
I should have times cosine of 3x. Okay, so that's my first part of my particular solution, and then my next part of my particular solution.
Oh, we need the C in there too.
Yeah, if I want a general solution, I need my C1 in here. You guys want a general solution?
But you didn't differentiate it, so you, or you didn't do the integral, so you, do you need this C?
He did one of the integrals.
Yeah.
Oh, you're right.
Yeah, that's a fair complaint. You might do something like this,
It's in there somewhere.
right, to make it so that it doesn't have the plus C on it, definitely, right, because now it's a definite integral. And then you'd add your C1 here. But, and then you slap your cosine of 3x. And then you add your mu2 was, that was the one that was okay. That was minus cosine of 3x over 9 plus C2. And then that should get multiplied by, yeah, that should get multiplied by a sine of 3x.
And you take this whole to be B or A integral.
Yeah, this is a hard problem.
Why do they always do that on
Why
number
is it
one?
all?
I don't know. I'm going to change that one too, though, because this problem is a little bit, like, is obviously fairly rough for problem number 1. It could be as simple as adding to the instructions, please remember that the integral of secant of x is this thing. Right? Like, that would be okay? But otherwise, I feel like this problem is a little harsh for problem 1. Sorry about that.